Question 7. It's all about the radians. Make sure your calculator is in radians because the question, if we just look, it talks about angles and radians. We need to know 2 formulas for part A and B, and if you know them, the part A and B will be really, really easy. Let's just get that out of the way. It's blocking my number 7 view. So the length of the arc, this is just to use when you've got angles in radians. Arc length, so L equals r theta, where r is the radius. That's a funny theta. R is the radius. It looks like a bum on its side. R is the radius, and theta, aka bum. What is that? That level looks like a fetus. Theta is the angle in radians. So you must know that formula. And the other one, which is the area of the sector, again, only used when your angle's in radians, is a half r squared theta. R squared. That is not a theta. That's disgusting. Right. So part A, we've got to find the length of the arc, BC. So arc length is L equals radius, which is 6, times the theta, which is 0.95. Work that out, and we get 5.7. We'll put centimetres because it's the arc length. The area, straight away, we're going to use area equals a half r squared theta, so a half times 6 squared times 0.95. Typey. 17.1 centimetres squared. Dead easy. 4 really easy marks, especially for question 7. Very nice to you there. Next question, a little bit more work. Part C. We've got, it tells you some information about point D lying on the line AC, and is such that AD equals BD, the region R. A lot of blurb there. It's not telling you anything that you can't see from the diagram. You've got to show that the length of AD, colour in AD, is 5.16. So we're going to work out the length, and hopefully it will be 5.16. So that length is a missing length. Let's just call it X. So what we've got now, we've got a triangle. You can see, it does tell you in the blurb above, but it does tell you that AD is equal to BD. You can see those little equal lines, but it tells you below as well. So that means that the angles at A and the angles at B are also equal because of the properties of an isosceles triangle. You'll need this information for what we're about to do. We've got to find X in a non-right angle triangle, so it's either sine or cosine rule. You can use the sine rule as long as you've got a complete matching pair, as in a side and an angle. We've got 6 centimetres. Okay, we've got a matching pair, as in we've got X and the 0.95. We're going to use those. And we do also, or we will also have a complete matching pair using the 6 and the other angle. Now, the other angle isn't told, but we can work out that other angle. All the angles in the triangle add up to 180 degrees. I know that, but because we're not talking about degrees, we're talking radians. What's that? Oh, they all add 180 degrees is the same as pi radians. So those 3 angles add up to pi. So if we just put on our calculator pi, take away 0.95 and 0.95, we end up getting, and I worked this out earlier, 1.24. So that's pi, which really is the 180 degrees. Take away 2 lots of 0.95, 1.24. So that angle, D, is 1.24. So we do have a complete matching side and an angle, and we have the side we're trying to find and the opposite angle to that. So we can use the sine rule. So we can do the X over the sine of the opposite angle, so the sine of 0.95 is equal to 6 over the sine of 1.24, which was that missing angle we worked out. It's up to you how you rearrange it. I usually work out the right-hand side and multiply everything by the sine of 0.95. Make sure, again, your calculator's in radians, but when I work that out, I have got the answer somewhere. I got 5.16 to 3 significant figures. And it's in centimetres. And it says show that the AD is 5.16, and we have shown that it's 5.16. Brilliant. Next question. Right, now we're finding the perimeter of R, so let's just colour that in. R is the shaded bit, so we want the perimeter. Now, I always ask myself, it's only 2 marks, so it shouldn't be that difficult. I always ask myself, is there anything that we already know? Anything we already know, Waterhouse? Yes, the arc length. The arc length, if you remember, that was the answer to question part A, is 5.7. So let's go back, and that's 5.7. Brilliant. Anything else that we know? Whoops, where have you gone? We know that X, which was that length we've just found, that's 5.16. Now, I know that length isn't part of what we want to know, but it will help us work out that little area of DC, because all of this line is 6 centimetres because it's the radius. Can you do all of that line? Just, it'll look messy. Use a black pen. Oh, green. All of that line is 6 because it's the radius, so we can use the 5.16 subtracted from 6 to work out the little bit of area, and that gives us 0.84. Well done. So the only bit we've got to find now is this bit here, and we already know that because it's exactly the same as the other side, which was 5.16. So to find the total perimeter, it's just 5.16. Oh. Didn't. Plus the little bit, which is 0.84, plus the 5.7, which was the arc length. And that all works out to be 11.7. Ta-da! Perimeter, we'll put centimetres. Now for 4 marks, so this is going to be a little bit more work apparently, the area of R, giving your answer 2 significant figures. So the area of the grey bit. Now what we need then is the area of the big arc sector area, which we know from before was 17.1. Yeah, that whole sector area was 17.1. It was the answer to part B. And we need to subtract the triangle. We need to take away triangle ABD. I thought you were going to write ABD. What's that? All right, okay. Now, the area of a triangle, yes, we know areas of triangles is base times height, half base times height. We don't do that here. We need to use the formula. We're going to write it that you need to learn, which is area of a triangle is half AB sine C. I.e., you have to do half multiplied by the 2 sides and the angle in between. So it's up to you which one you'd pick, but I'm going to pick the half times. Then I'm going to use the 6 centimetres. So half times 6. Oh, what happened there? Huh. Bit of a technical hitch there. A half times 6 times the 5.16 times the angle between them, the 0.95, sorry, the sine of 0.95. And if we work all that out, we end up getting, I don't know, I'll work it out now, can't find it. 0.5 multiplied by 6 multiplied by 5.16 multiplied by the sine, make sure it's in radians, of 0.95. And the triangle, we end up as 12.59 something, something, something. I didn't write it down because all I did then is I just did 17.1, subtract that answer that I had, and we end up at 4.51 to 2 significant figures. 4.51 to 2 significant figures. Concerns me slightly because I got 4.52 the last time.
4.51 to 2 significant figures.
Oops. That's why I didn't get. I got 4.5 to 2 significant figures. I can't read my own writing. I had to do it to 2 significant figures because the question asks for 2, so it's 4.5 to 2 significant figures. Oh, glad that's finished.